Welcome to this video. In this video, we will practice data wrangling skills and exploratory data analysis skills using the pandas package in Python. So we have data coming from this file called internetcompanies.csv. You can open this file in your text editor or even in your spreadsheet application. It's basically a text file. CSV stands for comma separated value, which means the different data fields are separated, the entries are separated with commas, as we see here. Now we can load a CSV file into pandas using the function readCSV, and with .head we can look at the first 5 entries in this file. Now this file, briefly speaking, lists properties of internet companies in 2015, including the country, market capitalization, cash, and revenue. So if we scroll down, we have a couple of questions to answer about the data in this file. But before we going there, we need to make this file, or the data in this file, analyzable. And as you can see here, we've got some idiosyncrasies in this file that we need to address. For example, all of the numbers are not numeric. They're simply text data, and we have a $sign in the beginning. Some of the data entries are missing, and the missing values are indicated with this $dash in the data. So let's look at the end of the file, the last 5 entries in this file. If we do .tail instead of .head, you can see some examples of those missing data entries. One more thing is that those numbers are reported in millions of dollars. So we need to multiply each number by 1 million to get to the actual value. So those 3 steps in this particular example are an example of ETL processes, which stand for extract, transform, load. There are a couple of steps we need to do to make our data amenable to analysis. All right. So we need to take care of that first $sign, and we need to convert this the value to a number. So what I'm going to do, I'm going to start with this part. Now feel free to pause the video for a minute or so at any step and try to do it on your own. Okay, so let's start with removing the $sign. To remove the $sign, there are a couple of ways we can use. Now something very useful if you've got a data frame is to look at the D types, and D types stands for data types. That's going to tell you the data types for each column in your data frame. In this case, we see that all of them are object, which means all of them are represented as string. That means we cannot call any function that expects a number on a string. So we cannot say, for example, data market cap .mean, the average market cap. That obviously doesn't work because you've got a string. And the arrow here, if you scroll down, is going to tell you that, I cannot convert this string to numbers. We have to do it on our own. Okay, so let's try to solve this issue. We need to take care of the $sign. If you take a look at market cap here, how do we take off the $sign? There are a couple of ways of doing this. One way to do it is to figure out a solution for this problem on one string. And then once we do it, we can iterate over the series in this case and repeat the same process. So in this case, I'm going to try to figure it out on one of these values. So what I'm going to do, and this is a technique that I often employ and I find it very useful in the context of analyzing data in data frames and series, is to simplify the problem and work on it for one single value. That's step 1. Step 2, design a function that we can call on this value. And step 3, apply the function on the whole series. Okay, so step 1, let me figure out how to do it on this one singular value. So the way to do it is to go back to our knowledge of string data type and also the string operator and function. Two things are useful here. One method or function we can use is the replace function, and we can replace a $sign by basically nothing, and that will take care of the $sign. Another way to do it is to remember that a string is a sequence, so we can index it and slice it. So we can slice the string from 1 to the end, and that will exclude 0, and 0 being the $sign. Okay, so what I'm going to do here, I'm going to, out of extra caution, and I'm not sure if there are extra spaces here or that's a formatting issue, I'm also going to take out the extra spaces by calling the method strip, which will take the leading and trailing white spaces. Okay, so I have figured out this solution for one single value. My next step is to do the following, is to create a function, convert, that takes that string as a parameter. And then with this function, what I'm going to do here, actually I don't need s here. This will be incorrect because s is going to be the input for this function. And then the output is going to be what I am returning. So I'm going to return that as a result. So that's a self-contained function. And I can convert, for example, 547, and I'm going to get 547. The next step is to call this function on each element of this series. Now, the best way to do this is by using a function called apply. So apply is a function that we can call on a series, and this function takes another function as a parameter. It basically, as the name implies, applies this function along the series or an axis of the data frame if we've got a data frame. In this case, we've got a series. So here I can apply convert here and get myself this thing converted. Now we're not done yet, because although we kind of took out the $sign, we still have object as a data type. So we still need to go ahead and convert this to a number. So to convert this to a number, we can convert this in the function convert. So I can either convert the string to an int or a float. In this case, int is fine. I can do float as well, but let's do int and or float. And then if I apply convert here, what I'm going to see here is that the data type is int. Now, although the numbers look the same, there is a big difference, because with this new series I can use any mathematical functions such as mean, because I've got numbers inside. Alright, so the last step is now to multiply by 1 million, since we would like to convert these values to the real values, which are in millions of dollars. So what I'm going to do here, I'm going to modify this to 1 million, and that's going to take care of that conversion. I'm going to do float instead of an int, simply because it's more general if we've got some decimal points, which we don't have in here, but for the sake of completeness, I'm going to make it float. Okay, so now that we've done this one, we need to store it in the data frame. Notice that what we've done here did not change the data frame. If I inquire about the data in the data frame, it's still the same. I need to override this data. So what I need to do here, I need to assign this data back to the data frame. But data market cap equals data market cap to apply convert, and this is going to override the data in the data frame. I'm gonna call it market cap 1 for now, because I want to show you another way of doing this. But let's check that this has been registered here, which seems to be the case. So we've got the original data in market cap, and then we got market cap 1, which is the result of that conversion. Okay, so what I want to show you now, I want to show you another way of doing this using vectorized string operations. So you can pause for a minute and try to do it on your own. But basically what we've done here, string functions on one single string, is something that pandas offer as a vectorized function that we can call on the series. So we can start from data market cap. That's the original data here. And then we can call str for the vectorized string functions. And each one of the string function has an equivalent vectorized function. So if I do strip here, I'm going to get this function applied on all of the series. And if I do str1 to the end, slice 1 to the end, I'm going to get this, and let me delete this part, this over all of the series. Okay. Now I want to convert to a number, so I can do either apply int or apply float in this case. And that's going to give me the float, and then I can multiply by 1 million, and that's going to give me the results in million. So either way, those are equivalent. This one is more generalizable for anything you want to do on any element in a series. This one is faster if you master the vectorized string functions. And they both are going to give you the same thing. So what I'm going to do now, I'm going just to save this one eventually in the data frame, and then I'm going to do data.head. Let's move this one above here and run data.head, and that's going to give me that a column converted. Of course, I'm not done yet because I need to do this on revenue, on cash and revenue as well. So cash and revenue, I'm going to pull cash here, and then I'm going to apply the function convert on cash. Now I'm going to go ahead and run the code, but I'm going to get an error here. And the error here has to do with this floating, with this missing value entries. Because if you got $dash, you're converting it to dash, and then if it's a dash, it can't be converted to a number. So what this question is asking you about is asking you to replace these with missing values, either none or missing values. So here in the function, I need to make it address that situation when you've got a dash. So what I'm going to do, I'm going to take a look at this string, which is the result of the transformation before I convert it to a float. Let's call this one C. And I'm going to create that variable C here. So if C is not equal to one single dash, then I can go ahead and return this. Otherwise, I can return, forget the else, I can return none. Which means now that my function is going to be able to address the situation when I have got that missing value. And you can see that I've got missing values here, here, and there. Now let's take a look at the vectorized string solution. The vectorized string solution is suffering from the same problem, simply because I'm using the same transform function to transform, which is apply float. If I do this on cache, I'm going to get the same error that I cannot convert to a float. So either I need to write a custom function that, depending on the value here, it's going to give me none or the float of that value. So lambda x is going to be float of x if x not equal to a dash, else none, right? Which is kind of one statement conditional liner to replace that if statement in the function. Okay, so we can do that, except that this thing is becoming a bit unwieldy. So from a readability perspective, it's just kind of becoming a bit hard to understand what's going on in here. What I'm going to do, I'm going actually to benefit from a function that pandas provide called toNumeric. So toNumeric, if you remember this function, is a function that takes a number or a series and converts it to a number or a series. But the input can be a string and the output is going to be a number, as the name implies, right? So I can do toNumeric 3, 4, 5, and I get 3, 4, 5 as a number, right? So to prove that this is a number, I'm going to use the type here, and that's an integer here in this case. Okay, so that's great, but what if I have this dash? Well, I'm going to get the same error. This one is cannot be converted to an integer or a number, generally speaking. So how do we address this issue? We're bumping into the same situation. Now, it turns out that the toNumeric function has an extra parameter called errors that basically specify what you want to do in case of an error. The default value for that error, if we close this, if we expand this one, is going to be raise, which means it's going to stop and raise the error. Another option is called coerce, which basically means that that error is going to be a null value. Ignore, it means the error is going to return the same string. In this case, I want the coerce option because I want to coerce the error to a null value. Okay, if it has been ignored, it's going to be dash, but I want this option here. Okay, so what do we do with this one? Well, this one is a universal function. It means it takes a series, so I actually can call it on the whole series. Now, don't forget that this whole thing is giving you a series, right? So what I can do in this case, I can pass in this whole series to pd.toNumeric. And I'm going to pass this parameter to coerce the errors to null values. And you can see that we've got the null values taken care of here, very much like what we've got here in the first situation. Now, obviously, I need to multiply by 1 million, which is now possible because the data type is a float. So what I'm going to do, I'm going to multiply by 1 million, and I have got myself, this thing figured out. So either way, I'm going now to just override the data in the data frame, so it's kind of ready for analysis. That's data cache. And actually, let's do data revenue. Data revenue, I'm gonna do it with this second approach. All right. All right. So I'm going to create this, and let's take a look at the head of the data frame now. And you can see that we've got market cap, revenue, in cash converted. Now, what do we do with market cap 1? I'm going just to drop it. I don't want it, so I'm gonna drop market cap 1, and I'm gonna tell it that this is a column because by default it's gonna drop a row columns. This function will return a new data frame, hence I want to override my old data frame. Okay. So now let's answer the first two questions. Show the first record and show the last record. So the first record is basically the first row in this data frame. So this first row in the data frame is going to be this one. To extract a row from a data frame, and because we are looking for the first one, we can use the index selector iloc. So iloc 0 is going to be the first row, and that's going to be the answer for the first question. How do we get the last row? Now remember that the last row is at the end of the data frame, so it's at the index of length -1. So we can actually look at this one and do index 19. But also don't forget that Python also offers negative based indexing. So if you want to go backward, we can go negative -1, and negative -1. -1 is going to be the last row. That's test 2. And don't forget that you've got access to the head and the tail functions. Those functions are going to return a data frame, so you need to, when you put head 1, that's the first row, that's going to be a data frame, so you still need to go ahead and extract the series from it. So this will be kind of a more involved in this case. So I suggest you do the previous approach, but it's possible to do head 1 I log 0 and tail 1 I log 0 to get the first or the last records in this data. Okay, so now let's kind of take a look at part 2. I'm going to copy the questions here so that I don't keep scroll up and down. Part 2 is asking us to do various computations, basically some descriptive analysis based on the data. So first one is asking us to calculate the average market capitalization. Now once we've got our data frame, we can pull a column. So we can do data market cap. And this column is going to be a series on which we are going to call the average, which is mean. Now, as in all of these exercises, often I ask you to round these numbers to like a few decimal points using the function I provide. So in this case, I'm going just to round it. We don't have any decimal points, but I'm still going to round it just in case. Okay, so that's going to be the answer of question, the third question. You know, similarly speaking, we can calculate the average of cash. And the beauty of null values in pandas is that once you note them as null values, missing values, pandas is going to take care of them when you call any of the built-in functions. So there is no need to filter out the functions. So I can do cash here. And that's going to be this number. So there is no need to take care of them manually. So like you don't need to say, okay, drop NA and then dot mean. Basically, if you call mean and you've got null values, Panda is going to remove them anyhow. So the next question is asking us to compute the mean of cash to revenue ratio. So we need to define another series, another column in the data frame, defined as cash divided over revenue. So let's not forget that cash is a series and revenue is a series. And thus we can combine them using any of the built-in operators such as divide. And Pandas is going to align the indices. So basically it's going to align, divide this one over this one over this one, and so on and so forth. So this is actually very handy, since the only thing we need to do here to calculate this, to do this calculation, is to divide data cash over data revenue. And that's going to give us this series here. The question is asking us to compute that average. So we have two options here. Either we store it in the data frame if we think we need to access it down the road, or we can just use this one and calculate the mean on it. What I'm going to do, I'm going to store it in the data frame just in case we need to have access to it in the future. So I'm going to create another column called cash to revenue. And this column, I'm going to take the mean of it. So the answer for the fifth question is going to be, going to round this one, data cash to revenue dot me. And that's going to give us the answer here. Okay. So we could have taken, we could have rounded all of the values here and then take the mean. Or we can take the mean before rounding them. Either way, the question is not very clear on whether you have to take the averages and then the mean of the averages or vice versa, and anyhow they return the same answer. The next question is asking us what companies have a cash to revenue ratio less than 0.5. Return the results in a list stored by company name. So it's good that we actually store this in the data frame because we need to access this data frame to answer the question. What I'm going to do, and we can take a look at our data frame here, you can see that we've got this in a column after rounding, so that's fine. What we can do here, we can filter this data frame based on cash to revenue. So that's a masking operation. Remember, a mask results when you take a series and involve it with any operation that returns a Boolean. So if you've got a series of numbers and if you compare those numbers with 0.5, which is what the question is asking us to, we're going to get a series with true and false. This series of true and false is called a mask, and we can use it to select based on a criteria. So we can do data at that mask, and that's going to give us the subset of the data frame corresponding to those entries when this the value is true. So this is a data frame, and the question is asking us to report the companies. So we need to extract a column from the data frame. And furthermore, it says it should be a list sorted by company names. So this is a series. I'm going to do, I have two options. Either I sort the series and then convert to a list, or I convert to a list and sort the list. So to sort the series, I can do sort. And if you've got a series, you've got two options. Either you sort by the index or you sort by the values. So in this case, I'm going to sort by the values. And I'm going to convert to a list using the function toList. Or I can do sorted of that. If I do call the function sorted, which is not a pandas function, it's a Python function, is going to convert this whole thing to a list and sort it. So, either way, they're going to give us the same result, which is the answer for question number 6. Question number 7 is a question about missing values. How many companies do not report cash? That basically involves going to that series, cash, and looking for these missing values and counting them. So there are a couple of ways of answering this question. One way to answer it is to drop the null value and calculate the length, and then subtract that from the length of the whole series. Because if you do the length of data cache, that's going to be 20, and then what you can do here, you can do minus length of data cache dot drop NA, and that's going to be 5. So that's one way to doing it. Or the other way of doing this is to actually use the function isNull, which is going to give us a mask. So isNull, if you remember from the discussion of missing values, is going to give us true and false depending on whether this is null or not. So in that case, I'm going to get true here. Right? Now, the question is, how do I use this one? Well, this one is a mask. If you do data at data cache is null, you're going to get a subset where cache is null. So you can actually take the length of that data frame, and that's going to give you the same number. All right, the next question is asking us to report the number of companies in each country and then store the results in a dictionary. So there are a couple of ways of answering this question. The natural way of doing it is using group by. So we can group by our data by country, and that's going to give us a group by data frame object. And then we are interested in company. That's going to give us the series group by object. And then we can call the aggregation function count, and that's going to give us count here. So in this case, I can actually convert it to a dictionary using the function toDictionary. That's one way of doing it. The other way of doing it is actually to benefit from the fact that country itself is in the data frame. It's a column. So if I do data country, I've got myself a series. And what I want to do is count the instances of each country, how many often we've got USA, China, and Japan. So what I can do here, I can use the function value counts. And value counts is going to give me the same count. Although by default, value counts is going to order by the count descending, and the group by is going to order by the key here, which is country, ascending. So eventually, if you're looking for a specific answer, order-wise, you will need to sort either one of these. Now, another way of doing it, which is slightly a bit convoluted, is through hierarchical indexing. So what we can do here, we can actually index by both country and company, do the count, and then that's basically going to give us something very similar to the group by result. So if you remember here, data had the default range index from 0 to length -1. But what we can do here, we can say, okay, give me set index. Let's set the index to be country and company in this case. Now, in this situation, I only care about one of the columns, because if you do it, you're going to get like a hierarchical index. You're going to get a hierarchical index on the data frame. Obviously in this case, I don't care about all of them. I only care about one of them. So what I'm going to do, I'm just going to select market cap, and that's going to give me a series. Now, as I said, this is a bit convoluted, but it kind of serves to show the same, the same result. Because remember, when you do the count, when you do an aggregation on a multi-index, you have the option of specifying the level of aggregation. So if you call count here, it's going to be the grand count. But if you do the count on level 1, you're going to do the count by company. If you do the count on level 0, you're going to get the count by country. Which is very similar to what we've got with a group by. So again, there is no kind of natural preference here. I'm going to get the group by since it's kind of the most straightforward way of doing this. Let's comment out those two options. All right, so we've got question 9, which is about extracting the company that has a name that starts with a lowercase letter. So if you take a look at the data, and because we've got 20 data points here, it's obvious that here eBay is the company that we want to extract. So we want to express this fact that the first letter is lowercase. How do we do that? Well, there are a couple of options. One of them is to kind of try to figuring it on one single value, as I did above, and write a function and apply on the series. My strategy is the following. I want something that returns true and false because I want to use this thing as a mask. So let's do it. Let's say you've got S and S is eBay. How do you know that the first letter in this string is a lowercase? So one way to do it is to extract the first letter, and to extract the first letter we can do S of 0. S of 0 is going to be E. Now the question is, how do I know that this is lowercase? There are a couple of ways. One of them is to test whether it's in A, B, C, D, E, F, G. I'm not going to type the whole English alphabet here. You get the point, right? Or if it's E with capital E is going to be false because this is not in A, B, C, D, E, F, G to Z, right? We've got two problems with this approach. One problem is that we're going to type in 26 keystrokes for English. The other problem is that it doesn't generalize beyond English, say to another Roman language where you've got upper and lower casing, but you've got other characters with accents, for example, in French. So instead of doing this, I'm going actually to benefit from the function called toLower. So remember the function upper and lower in the string. Let's do head here. In the string type, those convert a string to upper or lower cases. So if the string is in lowercase, it means it's equal to when you convert it to a lowercase. It basically means the conversion didn't do anything. So this one is going to be true because E is equal to E.lower, meaning lowering the lowercase e is not going to change E. But obviously it's not going to be true if it's a capital E. Okay, so that's great. What I'm going to do, I'm going to say start with lower. It's going to take S as a parameter. And as I've done above, I'm going to return this. Okay. So the next step is to take a look at company here. And again, we're only interested in company. So we don't care about country, and obviously market cap and cash are not even string. So we need company. And what I'm going to do, I'm going to use the same technique. I'm going to apply the function starts with lower on company. And you're going to get a series of true and false. So what to do with this series? Again, don't forget a series with true and false is a mask. So you can use this mask to select from your data frame. Now in this case, you basically got it here in the subset of the data frame in which the mask is true, which is the row of eBay. Now the question here, let's take a look at the question again, says what company has a name? So we need to nail down this company. If it says what companies, we probably can return a list, but it says what company. So I need to extract eBay from this thing. So what I can do, I can index my data frame. I can index it by company and then take 16. But I'm not going to plug in company and 16. And the reason is, let's say the data updates and eBay is no longer in position 16. My solution now breaks down. Instead, I'm going to use iLock, because no matter the order in the data, I'm going to get this really in the beginning of this result. So I'm going to get the first row, first column, and that's going to kind of zoom in on the value here. So iLock 00 is going to give me eBay, which is the answer I'm looking for. I'm going to suggest another solution, and this solution is going to be based on regular expressions. So what I'm going to do here, I'm going to get a data company, And I'm going to try to generate the same mask using regular expressions. So here is what I'm going to do. I'm going to call str to access the vectorized string functions. Now this solution is more advanced and more complex because it kind of requires a good knowledge of regular expressions. But let's express this idea that a string starts with lowercase using regular expression. The first thing you need to figure out is what function you want to use from those regular expression functions. And because I'm looking for something that returns either true or false, I'm going to select a function that returns true and false. I've got contains and I've got match. Contains is more flexible than match. As the name implies, it means contains in any position, which is not what I'm looking for. I'm looking for exactly the first position. So I'm going to match this with a regular expression that is going to basically match that condition. Start with lowercase. So let's express it. Again, it's a bit kind of technical here, but let's do it. With match, you want to specify where you want to start and where you want to end. I'm gonna start in the beginning of the string. So this tick, it means beginning, and the $sign has a special meaning, which means the end. Next, I'm going to say that the first letter is lowercase. So the first letter is going to be A to Z in lower cases. And I don't really care about any other letter beyond the first one. So what I'm going to say after this one, give me any letter, dot, and repeat. It could be one more, or one or more with plus, or zero or more. Let's say a company only has one single letter as a name. That may not be likely, but in that case, it doesn't affect the solution. So that's going to give me a similar mask with a true value here where eBay was, right? And obviously the trick here is in mastering this syntax. Again, this is very powerful. If you master regular expressions, many complex problems become really, really easy with regular expressions, obviously with string data. But that's the same idea. Once you get your mask, it's basically the same, set of steps. You're going to do the same. You're going to do this, ilog00. It's going to give you eBay. All right. So now that we are at here, I think we've got one more question to go. Calculate the total market capitalization per country and store the result in a dictionary. So this is very similar to when we counted the number of companies per country. This is a group by question. So what we can do, we can group by country and then do the sum of market capitalization. So I'm going to call group by country, right? That's going to give us group by the data frame group by object. And then I'm going to pull here market cap, and that's going to give us the series group by. And next I'm going to call the appropriate aggregation function, and the appropriate one is the sum. It's asking us for the total. So the sum is going to give us the sum per country. Obviously this is a scientific notation. It means 6.38 and 8 zeros. I've moved the decimal point 8 places to the right. Well, anyhow, this question is asking us to convert to a dictionary, and in this case I believe we will see those numbers in the floating format. So test 10 is going to be this. And what I'm going to do really at the end, I'm going to restart and run all, just to make sure that my notebook is reproducible from the beginning to the end. Many often, if you have a long notebook and you end up going back and forth in between cells, you end up creating some dependencies, which if they're not observed or no longer exist, are going to create errors. So if you're going to test your notebook, and there is a tester case for it, you just need to make sure that you restart and run all, and it's going to give you the correct results as the end. All right, so that summarizes this exercise. Again, this exercise shows us kind of the power of Python and pandas to process data. And very often in processing data, we need to make it useful for analysis by going through some step transforming and extracting and creating some useful extra columns before doing the analysis.